SDN WAN. SDN WAN? Wait a minute, didn't we talk about SDN last week? We talked about data centers and we had this Contrail product that, you know, when you were spinning up using OpenStack, these compute and storage resources, and now we need a network, an overlay network to get these virtual machines communicating to, you know, amongst each other. We use something called Contrail to do that. You know, it interoperated with OpenStack, and we could orchestrate in a cloud environment network connectivity. But now I'm not really working in the cloud environment. I want to take those same concepts and apply them to my WAN, my wide area network. I need the same things. I need to make this simple and faster and better, right? And that's our goal. So I want to take the whole concept of SDN and apply those concepts to a WAN. What's a WAN? Wide area network, right? It's a network that's not all in one building, for example, right? It might span an entire city, an entire state, a country, a province, or the world. You know, WANs come in, you know, various shapes and sizes, right? And there's a lot of them, and a lot of customers want to buy WAN services. I need to connect all my branch offices together. How do I do that, right? So SDN, right? Remember, we had a definition last week, software-defined network. Remember, our goal was really to completely separate the control plane and from the forwarding plane, and then centralize that control plane, right? And so I get a big picture view of my network. It's not each device operating with its own idea of how things are running. A centralized, separated control plane that can automatically program the forwarding plane. And that's what we're trying to do, the same things we were trying to do in the data center environment, right? So I need this to be quick, I need it to be simple, I need it to be fast, right, and nimble, be able to, you know, have this happen on the fly, a lot quicker than it currently does, right? And that's our goal here, right? So as you look at networks today, if I'm looking at this example of a WAN network on our screen, each one of these devices, each one of these routers in this diagram has their own individual control plane, their own view of the network, their own tunnels that are passing through it, their own amount of the traffic that's flowing through there, its own view of the network in a lot of ways. And I have no visibility, if I'm router A, about the tunnels and the data and the traffic that's flowing through router B and C and D and E, right? And that's the problem with these distributed control planes. I have to program these, monitor these, maintain these, upgrade these, control these, right? And that's tough, right? So remember, our goal of software-defined networking, no. I don't need control planes on those devices. I need them just to forward, right? I need a good, fast, scalable forwarding plane on these platforms. I'm going to take the control plane off and centralize that. Remember, that's SDN, software-defined network, and separate the control from the forwarding and centralize the control plane. And what this allows me to do is this centralized control plane has a view of everybody's tunnels, all the traffic flowing through the network. It has a bigger picture, a bigger database of information that it can make forwarding decisions on. And so it's a better way to optimize the forwarding and better utilize the forwarding components on your network. And that's the idea here, okay? Centralized control, centralized visibility. And so I need an SDN controller. We talked about Contrail networking as being an SDN controller in the data center space, right? Well, we're in the WAN space now, a little bit different architecture here, right? So I still need an SDN controller. I still want it to be my control plane, and I want it to be able to communicate with all the forwarding planes in my network and dynamically program them, right? The centralized controller with its bigger picture view of the network is able to better compute optimum forwarding paths for my customers' WAN traffic, right? So centralized view, centralized control. So let's talk about an SDN WAN controller. Juniper has a platform that performs exactly this role. It's called the North Star controller. This is your centralized control plane that can analyze a service provider WAN network, learn about all the nodes, all the links, all the traffic, all the tunnels that are traversing all of the forwarding components in your WAN, and dynamically compute optimum forwarding paths for label switched paths across a service provider network. It has the ability to analyze current MPLS label switch paths and to optimize those label switch paths and signal new label switch paths. And that's what we're going to kind of look at doing. This North Star controller runs in has a couple of different options for you, a couple of different functions it can perform. What's called the operator mode is where you actually discover your WAN, discover the links to the nodes, the tunnels, the traffic. You can monitor it, you can control LSPs, modify LSPs, provision new ones, tear them down. It's a complete, MPLS label switch path lifecycle management platform on a service provider WAN network. So dynamically spin up tunnels. And it also has a component called the North Star Planner component. Now remember, I'm a centralized control plane. I've learned all the tunnels, all the nodes, all the links. I've got this huge pile of data in one place about your WAN. And there's a planner component inside of the North Star interface that allows you to, that's basically called a network model, stored on the North Star controller. And so I can use that model for capacity planning purposes. What would happen if we added a new link between the Chicago and the Santa Fe router? What would happen if we added new tunnels? How would they be routed, based on these customer requirements? So what would happen if the Denver router failed, or when we lost the link between Chicago and St. Louis? How would the tunnels that are using those links and nodes be rerouted? Could they be? I can do things like that, right? Inside of this planner interface, so you can do failure simulation, failure analysis, capacity planning. It's kind of cool that I can not only manage my complete LSP WAN environment for my customers, but I can also use the planner interface to kind of figure out how my network could be optimized, right, in times of crisis, or better use my equipment, reduce my capex costs. So some words we need to know, right? If we're going to deal with these types of SDN WAN controllers, specifically Juniper's North Star controller, a couple different things. The North Star controller is something called a path computation element, PCE, and that's the control plane. That's the North Star controller. It's the device that has learned everything about your WAN, right? All the tunnels, all the nodes, all the links, all the traffic. I know all that. I've got it in a centralized spot, and then what they'll tell you is the North Star controller has industry-leading path computation algorithms. These are just simply the best math formulas in the world. You see, I'm a service provider. I have hundreds of clients whose traffic is flowing across my WAN, and I've got a new customer I signed up today, and of course they need a 100 meg MPLS link between Sao Paulo and San Diego, and they need it to be redundant. It can't go over shared links. They need bidirectional. They have all these requirements. And so I've got to look at how my network is now with all the current label switch paths. Can I actually place this type of demand on my network? Right? What would be the most efficient way that I could route this to meet the customer's latency requirements, bandwidth requirements, service level requirements, redundancy requirements? Is it possible to compute a valid path that meets all this customer's label switch path requirements across my current WAN? If I did that, would I starve other label switch paths? Would certain tunnels not be able to be signaled, right? And so there's nothing better in the industry to figuring out what's the best way to route this LSP with these demands across your WAN, given how it's currently configured, right? So pretty slick. And so that's called the path computation element. Now, once he figures out the path, I've got to signal that out to the forwarding plane components. And those are called the path computation clients. And the protocol that's used between the PCE, the North Star controller, and the PCC, your forwarding plane, your routers or your switches that are going to forward the traffic in these label switch paths, is a protocol called PCEP, Path Computation Element Protocol. You might need to know that stuff, right? I don't need you to be an expert on the North Star controller. I need you to know this. I need to know it is used to dynamically signal MPLS label switch paths across service provider WAN networks in a dynamic fashion, and it does that by using SDN. It's a centralized SDN controller, also known as a PCE, that has a centralized big picture view of your network and can compute optimum forwarding paths for the label switch paths that are traversing your WAN and communicate those paths out to the path computation clients using a protocol called PCEP. The path computation clients are the forwarding plane. right? And those are the components I need you to know about North Star. Okay, just some of the pieces of North Star. There's kind of three legs to this horse here. The functionality of North Star, the first thing it can do is it can learn the service provider's WAN. You know, I peer with routers, you know, generally using BGP, I learn all the routes, I learn all of the links in the customer network, I learn all the nodes, I learn all the tunnels, I learn everything about how the service provider WAN is working. And then once I have that information stored on the North Star controller, I can use that centralized database of network knowledge to optimize how the label switch paths are signaled across your network. Maybe some links in the WAN aren't utilized at all, while some of the links in the WAN are currently oversubscribed. There's got to be a better way. Can I move some of these tunnels around and still meet my customer's service level requirements? And that's what I want to do here, right? So I can compute optimum paths and maximize my capital expenditure on all this WAN stuff, right? And then I also have the ability, once I'm done optimizing and computing these paths, remember, software-defined networking, I can dynamically program the forwarding planes to re-signal the label switch paths using the optimum flow pattern through my WAN, okay? All right. What? And there's another component of North Star, and I haven't messed with this one too much, and it's called North Star Analytics. You can install a special version of North Star. North Star is software. It usually comes in a virtual machine. Hey, that's kind of cool. Software-defined networking that runs in a virtual machine. Wow, I can spin this up in a virtual machine and run this in a dynamic fashion. Kind of cool. You know, but there's also a way to configure North Star to just simply be a data collector. You know, using SNMP or, you know, shell scripts and things like that to collect more and more and more analytical data about your WAN for even deeper analysis, right? So there's additional functionality there, right? So again, from the Department of Redundancy Department, North Star, once you get it set up, you get it configured, and you get it speaking to the components on your WAN, it can see everything. I'll show you that in a couple of screens. All the nodes, all the links, all the tunnels, all the traffic. It's incredible the visibility you get about how your WAN is being used, right? Just extensive detail. A lot of information is learned about, you know, the data on your WAN. So let's look at North Star, the North Star controller. It's a web-based interface. Once you get the North Star controller virtual machine up and running, you'll browse to whatever IP address you assigned to the North Star controller, and you'll configure it. And there's a process you go through to configure the North Star controller. You'll configure the routing component to peer with a BGP, generally a route reflector in the service provider network. So it learns all of the BGP routes, right? All of the tunnel routing information. And it also peer using PSEP with the provider edge routers, that path computation element. And that's how I learn all the tunnels and all the data that's flowing through those tunnels and what their path is through the network. And I learn every single node and link and everything. And what you'll see in the interface is, of course, on the left-hand side, you'll see a little navigation menu. You can select things that appear in the main kind of pane right here. When you first log in, you'll be able to see all of the nodes in your WAN, all of the links. And down at the bottom, there's different tabs. There's a nodes tab, a links tab, a tunnels tab, a demands tab, and you click on the tabs, you can see every node. You click on the node, you can right-click, you can edit, you can pull up, modify. You can view everything about the nodes, the links, the tunnels, the demands on your network, right? Just right-click on it, view it, and it appears on the topology map. Like if I go to the tunnels tab and I click on a label switch path, it literally shows me the path. You know, which nodes, which links does this LSP traverse from the, you know, point A to point Z. That's what I can view. Okay? So that's what we're looking for. That's kind of the visibility. And again, I can see how my network's being utilized, every tunnel, every link, every demand. You can click on an LSP, you can click on a link, you know, maximum bytes, available bytes, number of tunnels traversing link, number of tunnels traversing nodes. Oh man, just more information than you could ever think about all of the tunnels across every device on your WAN. Everything. Incredible visibility. So it's a quick learner. Right? Then now we get to the kind of the signaling piece. Once I have all this information, and then I can remember modify some of these things, like the tunnels. It supports something called bandwidth countering. I've got a customer. They normally have a 100 meg tunnel. There's a big event. There's a migration. Something going on. They need a bigger pipe. You know, but just for this month. And so I can schedule that their label switch path is dynamically resignaled. Let's say they want double the bandwidth. I need 200 megs this month. Okay, cool. I'll schedule it for, I don't know, tomorrow, midnight. We'll go ahead and signal you a 200 meg label switch path, between your two sites here. And it'll be up, and it's automatic, and it'll be there for, when did you say, a month? And at the end of that month, we'll dynamically cut it back to 100 megs so you can save you some money. And all of this is done in a dynamic fashion, right? The customer's traffic never is interrupted. There's still flowing traffic. I'll pre-signal the 200 meg, switch the LSP, and then switch the customer traffic over to that and tear the 100 meg one down, right? In a dynamic, automated fashion. So that's kind of nice. I like that. I didn't used to be able to do that when I was doing this stuff manually. Customers have a lot of requirements. I'm very important. I'm a bank. I move a lot of money. And from the Department of Redundancy department, I want redundant connections between my San Francisco and my Denver branches here. And then now, what I mean by redundancy, I don't want those redundant links to go over the same link or the same router or the same path. I want this label switch path to use different routers, different links. So if somebody's digging a trench outside of, Boulder, Colorado, and they take out the path from Santa Fe to Denver, that's okay. I can come up through San Antonio and still get the, you know what I mean? And I have the intelligence to be able to signal label switch paths using the North Star controller to exactly meet these customer requirements. Right? Pretty slick stuff. Right? Maintenance. My heavens, we've got to take that router out of service this Friday because, I need to upgrade the software on that thing. It's a couple versions behind what we normally run, and I got to fix that. So how do I do that, though? Because when I go into North Star, my heavens, I see there's 75 tunnels traversing that router right now. What's going to happen when I reboot that router after that software upgrade, right? So what I want to be able to do is use the North Star controller to mark a node as being, or a link, being unavailable for maintenance. And when I do that, North Star controller will automatically recompute paths for all the LSPs that traverse the affected device and pre-signal around the failed, in this case, node, the one we're going to take down for maintenance. And the customer traffic is diverted and nobody knows anything's going on. I can do my maintenance, whatever I need to do on that device, bring it back into service, and if I want, I can manually end the maintenance event, which would allow North Star to signal the label switch paths back to their original, flow. So it's very dynamic in its capabilities, right? To signal label switch paths, in an optimum fashion. There's also, I mentioned earlier, a planner. I have this huge knowledge of your network on the North Star, all the links, all the nodes, all the tunnels, that's all here. And so it's really what it's called it's kind of a model of your WAN. It's stored on the North Star controller, and I can use that model to learn things that I really can't learn in production. And it's things like, what would happen if the Denver node went down? I mean, I could find out the hard way, drive up there and pour milk on it or something and see what happens. But it'd be better if I could simulate that. Simulate that link, that node failing, right? Simulate a customer needing 800 megs of LSP bandwidth for a weekend. What's that going to do? Can I signal that? What would be the path? Would the path that is available meet the customer latency requirements, right? And so I could do things like that on the model, and then so I would have confidence of, okay, well, if this is what I did in my production WAN, these are the results I should expect, right? And so that's what the North Star Planner is all about, okay? All right. Let's talk about, that's North Star, right? A software-defined networking WAN controller. Dynamically signal label switch paths on a service provider WAN network, right? Complete label switch path management. So now we're going to talk about another platform called Wandle. And Juniper bought a company, and I'm a little fuzzy on the years, but it's been several years ago. We bought a company called Wandle, Wide Area Network Design Labs, and they had a product called IP MPLS View. And what this does, it's very similar to North Star. And here's what it is for, right? It is used to primarily analyze a service provider MPLS or routed network, a WAN, and learn it, build a model of that WAN, And then it has algorithms that can be used on that network model to help optimize the design and performance of a service provider WAN. So let's look at how this is done, all right? So there's an IP/MPLS view server component. It's in virtual machine format these days. And so you can download from Juniper an IP/MPLS view virtual server, install the software on it, right? There's a little, kind of process you go through there. It runs, on a CentOS, KVM, hypervisor, and then there's a web client. Well, there's a couple different clients. There's primarily a Java client and a web client. You connect to the IP/MPLS view server, and you configure it to learn the WAN. Configure it to learn information about your WAN. How do you do that? Well, a couple different ways customers use this IP/MPLS view software. Some customers actually use this really to kind of monitor their WAN. I can configure the IP/MPLS view server to connect to all my WAN components using Secure Shell or SNMP and poll them and learn real-time information about how how my routers work and how the tunnel's doing, right? How's the demands flowing across my network? Are there any issues? So some customers use it. Service provider WAN service providers use it as a kind of a monitoring tool. It's very popular for that. But I say probably the biggest, largest use case of this product is its design and planning features. So let me explain this to you. Again, there's a Java client, there's a web client. The Java client is probably more functional. There's more features inside the Java client. That's the traditional Wandle client. More and more stuff has been ported over to a web, interface. But the Java client is still more functional than the web. And what the goal of this product is to build a model of your production WAN, right? How do I do that? There's a couple different ways, but basically I can import information from your WAN. The configuration files in this example, the configuration files on those routers. And some CLI output, things like show interfaces, show MPLS LSP, show chassis hardware, show interfaces extensive. I can get the output of those commands and import that into the IP/MPLS view server, and it can use that to build a model. I know all the links, all the nodes, all the tunnels, all the demands. I can import that data, and then congratulations, you have an offline model of your production WAN, right? And that's what I'm trying to do, because you know what I can use that model for? A lot of optimization and planning and failure simulation, and we'll see that. How do I build the model? We're going to look at a couple different ways. Live network collection, offline network collection, or nobody really does this, but you can build it manually, and that's a lot of fun. I can import data from all kinds of network vendors. This isn't a product that's been locked down. No, it only can work with Juniper platforms. It can import data from almost every network vendor you've ever stumbled across in your life, right? So I can understand config files from vendors and CLI output from all kinds of vendors. So you're not tied down. So here's what we do, right? Some customers will actually take the IP/MPLS view server and you will configure it to connect to all your routing components. In this case, all these routers. Here's a Secure Shell, here's the management IP, here's the credential. It logs in and it starts running commands. Show config, show interfaces extensive, show MPLS LSP extensive, and it starts importing the output of that into the we do it live. So this is a lot. It's still an offline model, but it's updated in live fashion, right? I schedule this collection, right? And so Friday night, connect to these boxes, run these commands, import all the data, and I've got a model. Cool, great. And I can run that anytime. It's more common though, it seems to be with our customers, that they prefer I don't really feel comfortable with this IP/MPLS view server connecting my production WAN components and executing commands. I don't feel comfortable. You tell me what commands you need. We'll connect to the devices. We'll do show config. We'll do show interface. And you'll see a list of the commands that are required for each vendor, and we'll save it into files. You can import it into there's an import network wizard that can import these files. It's just like doing it live, right? Or you can build it yourself. There's a few files. You can put links. Here's my nodes. Here's my links. Here's my tunnels. You can build it yourself. It's not really done that way for a production network, but it's used to kind of play around with WAN to learn it a little bit. And then here's the deal. Once I get that network built, man, this is an offline sandbox. I can do anything I want to. What would happen if this link went down? What tunnels traverse this now? How would those tunnels be resignaled? Can I resignal those tunnels, right? Would this oversubscribe certain links, certain nodes? I can do anything I want here in my sandbox, and it lets me know once I perform these, what happens if the Denver node fails? Once I simulate this, there's extensive reporting built in where I can analyze the effects of this event, and so I know exactly what would happen if this same thing happened in my production WAN, right? And that's the power of this tool, right? What would happen if? Now, what has happened, it seems like over the past really year, in my opinion, is this functionality, the IP/MPLS functionality, has kind of been ported over to Northstar. And so the Northstar Planner has a lot of this same functionality. So both of these products at this point can I think IP/MPLS probably has a little more stuff that it can do because it all hasn't been, completely migrated over, but that's kind of where things are going. Okay. So yeah, Tim, you're kind of right. Sounds like that's the way it is too. That's kind of the IP. And failure simulation, the same thing I can do with kind of the Northstar Planner. What would happen if what would happen to the demands and the tunnels and the customer service levels if this happened, that happened, the other? And again, I'm just trying to verify. I've got to certify my production WAN. I got to know what would happen, right? If the Denver router went down, I can't go, oh my goodness, what happened? I've got to know. I don't know how you get that. This node went down, this link went down, this site failed down, this card went down, this port went down. I can simulate all that. If this node and this link and this tunnel, what would happen? What would happen to everything else going on with my WAN right now, right? And that's kind of what this platform's been all about. So a lot of providers use that. I mean, I've got a big network. It's hard for me to figure this out with a couple cans of beer and a spreadsheet, right? And it doesn't even work. And so two things here. We talked about software-defined networking again, but in relation to a WAN. I'm not looking at clouds and spinning up virtual machines. I'm spinning up MPLS label switch paths for my customers in a dynamic, optimized fashion. Two platforms. The Northstar controller is our software-defined networking WAN controller, where Contrail is our software-defined networking cloud controller, right? And we also talked about a product called IP/MPLS View, right? Used to analyze and optimize your service provider WAN. So those are two things, okay? I need you to kind of be familiar with. I'm going to, move on to the next chapter now. Two more to go. So chapter 9, we're going to talk about something called Cloud CPE and a platform, called Contrail Service Orchestration. So let's get going. Right? We're going to kind of focus in this chapter about customer premise equipment, the typical services that a customer requires on that device that's at their branch office site, how it's traditionally been done, some ways to maybe optimize the traditional method of providing services to customers. And we're going to talk about a product from Juniper called Contrail Service Orchestration that can help you here, right? So let's get going. So how are things done? Hey, think about yourself, right? You just moved to a new apartment, new house, new somewhere. What do you want? I need some internet access, right? So you call whatever local provider. Hey, I'm moving in here on the 10th. I want to get. Well, it's going to be about 14 business days before we can send Jimmy out there with the truck and your little wireless router that you're going to need, and he's going to have to program that thing. We're going to have to check, what kind of service you're able to get. Oh my heavens! I'm gonna need a haircut before I get internet, right? And so I don't like that. That takes a lot of time, costs the service provider a lot of money. And if I'm trying to set up WAN service, I'm a business. I have branch offices. We're kind of opening up in all these different cities. And so, what do I need at branch office in Denver? Okay, well, my heavens. I need a router to get us onto the service provider network. And behind that router, I'd like to get a firewall maybe. And that firewall plugs into a switch. And maybe that switch plugs into a wireless access point. And that's how everybody on the branch. There's a lot of functions I need out of that customer site. How do I get them there? Right? And can I get them all in one box? I may not be able to get kind of the best in breed solution if I put everything on one box, right? Jack of all trades, master of none kind of deal, right? So, how's the world moving along? We know how it's been. Where are things going, right? We talked about cloud a little bit, public-private clouds, and these branch offices. My goodness, sending Jimmy out to all these branch offices, flying them around the country and setting them. That just brings a lot of money, a lot of time. I want this to be secure. I want this to be automated, right? That's the whole world these days. And so we're kind of let's try to shift paradigms here. Let's look at, I don't want to send Jimmy out there in a truck. I kind of like to change the way we're setting up these branch offices. I want an easier, quicker, better solution. And so we've come up with this concept, this cloud CPE platform. You know what? A lot of these things that these branch offices need, I can get these to run in virtual machines and provide these virtual network functions. Boy, I hope this sounds familiar to you guys from last week when we talked about what are virtual network functions. I think it was the last chapter we did. So what I can do is, instead of sending out this proprietary vendor specific, why don't I just send out a device that's just a standard open platform, standard x86 server running Linux with a KVM hypervisor on. And I can drop ship that overnight to the Denver office, the new Phoenix office, the one up in San Antonio we're open after we get done eating. And so I can drop ship that. It'll be there tomorrow. The FedEx guy will have it there, right? You just set it up. I've already got a point of presence in your building. Just plug this hole into this wire and turn the wireless access point automatically comes on. And we're all ready to go. And so you plug it in, you turn it on, it connects back to the service provider network, and the service provider will dynamically push down whatever virtual machines that cloud CPE platform needs. Right? That's what I'm trying to do here. So no sending Jimmy with the truck to configure manually all the services the customer needs. That's too slow. Right? Let's do this in a cloud fashion. So there's kind of an architecture here we're going to go through in the next few slides. Some of the names have changed, but it's very similar concepts to what we talked about in the cloud environment last week. I still need my underlay network. I need a point of presence at that customer site. A cable they can plug into the thing I do ship out there, right? I still need my infrastructure, my underlay network, right? And at the client side, I'm going to ship them this universal, customer premise equipment, this open x86 Linux KVM hypervisor device. I ship that out there, right? Now, the virtual network functions, that's what I'd like to ideally get this to is when the customer signs up, they go to a portal, they say, okay, I'm opening up this, I'm moving here, I want this type of service, I need a firewall, I need some NATing, I need some load balancing for these sites. And based on what they pick on this template, I dynamically provision the virtual network functions, and I can do that on the customer premise equipment platform out at that branch office, or if that CPE device is not capable, I can program that into the provider edge router, spin up the virtual network functions, and configure that provider edge router to route the client's traffic through it between Denver and San Antonio, however you want. Dynamic, right? You have the infrastructure orchestration. That's where the software-defined networking component comes in. That's what links all the virtual network functions and builds the tunnels to connect the branch offices together. And of course, the whole big piece would be something like OpenStack, which we talked about last week, which would spin up the virtual machines that create the virtual, that are running the applications that provide the virtual network functions that call out to the infrastructure orchestration piece, which is the software-defined network component that builds the tunnel that gets the traffic between the branches flowing through those VNFs. Isn't that cool? A lot of parts here, a lot of names, but some of the names are a little bit different than what we talked about inside the cloud space. This is kind of more of a WAN connectivity space, but the concepts are the same, right? So let's look at this cloud CPE thought process by using something from Juniper called Contrail Services Orchestration, CSO, right? Kind of a standards-based approach. I'm going to show it to you the architecture of this component. Plenty of open APIs, open standards. It's kind of a Juniper thing here, and we can communicate with all kinds of vendors, and I have a virtual infrastructure manager, which is kind of like an OpenStack component included into it. So let's look at it. Here's a picture worth 1,000 words, right? So here's the Contrail Services orchestration piece that's designed to automatically program. You see on the left-hand side of the screen here, this NFX 250. This is our Juniper's open CPE platform. It's a standard x86 appliance running Linux with the KVM hypervisor, and I can dynamically, in a cloud fashion, program the virtual network functions on there using CSO. Or a couple different components. I can also program physical hardware components. Physical provider edge routers. I can, spin up virtual functions on them and configure routing for those as well. But a couple pieces. A customer portal. Here comes. Well, let me start with the admin portal. If you see, I as an administrator, once I get Contrail Service Orchestration installed, configured, I will connect to that, and I will define service templates for my customers. Service offerings. Here's load balancing. You want load balancing services? And what I do by defining that template is I specify the actual virtual machines and how those virtual machines need to be configured to provide that function. I need this type of server with this type of application, this amount of RAM, this amount of storage, right, to provide load. I need something different for firewalling. I have a different virtual machine with different applications that I use for NATing. So whatever, you build that. And then the customer is going to open up a web browser and go to the customer portal piece of this, and they're going to pick those templates. Okay, I need WAN service, I need that service, I need firewalling, I need NATing, and then submit. And then, so what I have is inside of Contrail Service Orchestration, you'll see the OpenStack. This is what spins up those virtual machines that provide whatever the firewalling, the NATing, the IPsecing, whatever virtual network functions your customer wants. And also Contrail Network is included here as the SDN component that can dynamically program the overlay network to tunnel your customer's traffic through these virtual network functions. And it's all done automatically, right? And that's what we're trying to do here. So I'm not spinning up in a data center so much. I'm spinning up virtual network functions and software-defined networking more in a WAN environment to connect customer sites, right? Dynamically provision customers' internet access, which is the case here. Okay. Okay, so how is this implemented? Contrail Service Orchestration is a series of what are called microservices. They're actually implemented as a container application. So Kubernetes is included. And so I think it's the next slide. Let me show you, not the next slide, I'm sorry. That slide! I didn't mean to go that, I thought it was the next slide. All this stuff above the Juniper developed line are what are called microservices that are actually container-based applications that are spun up by Kubernetes. And so the reason we want to show you this is it's a very light platform. It doesn't require tons of resources. So remember, if you do the container piece, I don't need the hypervisor, I don't need the guest operating system. I just need to tune these apps to run in the container environment. A lot less horsepower required to spin these things up, and it's really easy to add in new services to this platform, right? So let me go back. I apologize for jumping so many slides. That's not a good presentation skill to do, but and that's what it means by all these microservices. And these provide the functionality. Hey, spin up this virtual machine. Let's build this network. Let's provide an admin portal. All of them are spun up as container applications. Okay. And that's great, right? What can I do with this? Well, one of the use cases for this is provide software-defined WAN services, right? The customer goes to the customer portal. I need this type of WAN service. I can dynamically provision the routing virtual machines, the security, the VSRX with whatever functions you need, and either program those virtual machines, those virtual network functions into your customer premise equipment or into the provider edge router, right? So I can dynamically provide WAN services using this platform. Security services. If I'm in a cloud network, some of these virtual network functions that I'm spinning up using CSO are virtual SRX firewalls. Again, that's a lot, right? That's a lot. It's a lot of security features that I can get just by sticking one of those in the path of customer traffic between the Dallas and the San Francisco office. It is a bank, right? So again, just some more things. It can program cloud CPE, customer premise equipment devices. I can provision virtual network functions on those. I can dynamically provision WAN connectivity, security services, and there's all kinds of apps, that I can plug into this CSO, and that means more services that I can sell. So it's a way to automate, kind of WAN services for your customers. Okay, in a cloud-based fashion, and it's very scalable. So let's say I have a data center in Silicon Valley, and I have another data center in the Washington D.C. area, and so I have Contrail services orchestration software running in each of those, but I'd like to kind of step back and centrally manage this, and so it's hierarchical in fashion. If I run into a scalability issue where I need a CSO in each data center so I get the performance that I need. But I want to be able to centrally configure those so I can drop back another level and manage multiple regional CSO instances, kind of from a central manager level, right? And then here's sorry, I kind of hit this one a little bit earlier, but here's all those different little microservices that are available. It's a product that has a lot of functionality, right? So, and the idea is this whole centralized service chain, right? And the customer comes to a web portal and says, I'd like this feature, and I want this much bandwidth, and I want this security functionality, and I need natting. Don't forget natting, and submit my order after I've typed in my credit card. And I can kind of crank out all these requirements to spin up the correct virtual machines and with the correct virtual network functions or physical network functions, and then use the Contrail component to build the virtual overlay network that would start getting customer traffic flowing through this service offering. That's the whole idea. The customer just wants to push a button, right? And this all happens in the background, right? I want a Big Mac with some fries and a Coke. That's all I want to do. Basically push those 3 buttons and hit submit. And just in the background, somebody's cooking fries and making sure they get the right amount of salt on there and getting me a soda and my Big Mac. There's a lot of, they've got to microwave that, right? Whole chain of things going on. Here's the cloud CPE, and the big thing being, if you look on this customer premise, little kind of rectangle here, that's where I mentioned earlier we have this NFX 250 platform, which is the just standard open Linux device with a KVM hypervisor. And if I want, if the customer has this new CPE cloud CPE component, heck, I don't need to do anything other than have them plug it in. It connects back to the service provider, and I'll just push down the VNFs that are necessary to give them whatever services they want. I can do this with this Contrail services orchestration piece. I like that, right? And so I've got a point of presence. So I have there's a cable in your data in your wiring closet. We've got that set up. So I can go in. I can
Well, folks, let's just hold on for 1 second. We may have lost Gordon's audio, but don't worry, he'll be back. He loves talking about this stuff. So hopefully it's not a tremendous amount of packet losses or anything like that. It's entirely possibly home network, corporate networks, Adobe Connect. We need a really smart, trained, certified networking people to keep these things from happening, which is everybody that's on this webcast. So everyone raise your hand. Looks like we got another Gordon Mosley coming in, maybe on a different computer. So we'll just give him a second to connect all the microphones and all that good stuff again.
Hey everybody, can you hear me?
Yep,
Am I back? Hey, I have no idea what happened. I just kept flapping my pie hole and something stopped working. So I had to leave and come back in. And sometimes that it just happens in this platform. So hey, thanks for your patience. Let's keep moving on, right? And so here's the designer component of CSO, where you can go in and set up all these templates. Okay, now the customer might want NAT services. So if they want NAT, I need to make sure these are the virtual machines that are spun up, the right ones with the right apps. Oh, they wanted what? They wanted a firewall. Okay, cool. Let me build a template with the virtual SRX pre-configured for what they need. This is what you do. This is kind of the dirt work you do to get all the service offerings available for your customers. That's all in there. Your admin portal inside of CSO is where you kind of go monitor how are my resources being utilized, right? How's this system performing? How's my WAN? I can see great visibility there. The customer portal is where your Freds and your Sallys, your customers that you sign up. This is where they can go to manage their services, view their performance. You just get all the information about. They actually get their own portal with just their own services and great visibility into that. So all of this, on top of the ability to, provision this stuff, it allows you to design things, you to monitor things, and it gives you the same offerings to your customers, right? Now you'll probably take this and modify it, put your branding on it, right? But it's a good framework to get started. You don't have to reinvent the wheel here. I just need to, change retread the tire, right? And so I can see, all the different applications, which virtual machines are the most popular, how's the performance of this network. So there's a lot more to it as well from that aspect. So that's it. So we just talked about some pain points here, right? When you just think about your home internet, right? When you want to sign up, they've got to send a truck and send somebody out with a device that somebody's got to program, configure, and test, and man, that takes a long time. And so we would like to can we do this in more of a dynamic cloud type fashion, right? And so we talked about this cloud customer premise equipment. From Juniper, it's a platform called the NFX250. We partner with large service providers around the world, and that's their actual customer premise equipment. And they can use a platform like Contrail Service Orchestrator to program that thing. Just drop ship it to the client, have them plug it in. We've got a POP in the building, just plug the wire in. And when it turns on, I'll dynamically push whatever virtual network functions the customer requires. Okay? And that's it. And Contrail Service Orchestration is a software platform from Juniper Networks that can do that for the largest service providers in the world. That's what we do, right? Hey, you're doing great. I appreciate you sticking this out. I know you must be tired. I'm getting tired, right? So we've got one more module to get through here, and this is going to build character, right? It's going to make us feel better. We're going to learn something here, and it's dealing with cloud, and we're still in Juniper Cloud Fundamentals. But how do I secure this stuff, right? What are some things I need to think about to secure any type of cloud environment? We're going to talk about a concept called software defined secure networking. What is that? In a software, what are security risks that I'm about to face, and how do I fix this, right? How do I secure this stuff? Legacy, how do we secure networks traditionally, right? Well, I've got antivirus installed on my laptop here. It's got a big old database of all the bad words that I shouldn't see coming in any file. And then, of course, that comes through the firewall, that north-south traffic. And so kind of something at the edge of the network, and then something like an antivirus, maybe a host-based firewall, on the machines that are actually connected to your network. You have this paradigm, this trusted model, that my network, no sir, my network is 1,000% safe. All the bad stuff is out there on the other side of the firewall. That's how networks started. All right, but come to find out, Fred had been taking his work laptop home, doing heaven knows what, and now he's bringing that dirty thing back into work. And my heavens, if he plugs it into the switch back in his cube, that bad stuff that's spitting out of his computer, it's never going to cross the firewall. He's going to infect Sally and the rest of accounting, and we won't be able to see it. It never crossed the firewall. My heavens, it may not be so safe in here after all. Do you know what I've moved to? I don't trust anything. Zero trust. It's all bad, right? And that's the other end of the spectrum, and that's kind of probably the safer model, right? It's all bad stuff. And so what do I need to do? I need to be able to push my enforcement of my security further down the chain, deeper into my what was previously thought to be safe network. At any point where somebody can access my network, any port on a switch, any wireless access point. Can I push security settings down to that level? I don't want to have to wait till it gets to the firewall, because some of it never gets to the firewall. All right, so let's fix this. So another thing that I might be able to do is, a firewall, it's an incredible platform. It's got a lot of knowledge. It's seen a lot of things, but it hasn't seen everything. There's a bigger world out there that we're not aware of. And so there are external services that are available that provide more information about threats that have been seen in other parts of the world. And it might be kind of cool if they've been seen in other parts of the world before they get to your part of the world. So that gives me some time to protect myself, right? And so I'd like to be able to leverage a bigger bag of resources to protect my network than I currently have on my firewall. And so we're changing things here, right? I want to use big data, and I want to be able to use machine learning across this big global pile of data. And when I learn something from that, I want to be able to automatically secure my network using that information. So how does this work, right? So what is machine learning? It took me a couple of beers to figure this one out, and I realized, wait a minute, I've done this. I used to run these email servers for a living, and my heavens, 90% of the email we got was spam. Isn't that depressing? And so 9 out of my 10 emails were just junk. And so how do I protect my network from that, right? And so we would have a spam filter, and what you would do is you'd show it some of the spam you were getting. Look at what I get. And it could learn that. It could look, this spam message, it's always got an HTML body. They always use these big fonts. They always include these little icons that you can't see. This is common. All the spam, and you could train it. Keep feeding it. Oh, I got another spam message. I could feed that into the spam filter, and it would learn its characteristics. And so it could learn what things look like. It could learn what's going on. And it could use that to predict things. Because what I learned previously, man, the last time I bought a used car, I had nothing but trouble. I'm just, if I go do this again, I know what to expect. So once it had seen enough spam, heck, when new spam came in it hadn't seen, boy, look at that. It's got that same big font that we always get. This just smells funny. And so it could learn and predict based on things that it's seen previously. That's what machine learning is all about, right? And so what I want to use that machine learning on is this big pile of data. I mentioned just a couple slides back that my firewall, it's got a device level view of the world. It's seen all the bad things that it knows about in its little silo, but there's a bigger thing. You remember it didn't see Fred's traffic on the switch down there that's corrupting Sally. I couldn't see that, right? It didn't cross the firewall. And it's even bigger. We talked about these third-party cloud-based threat feeds that you can get that actually compiles threats that have been seen on a global level. There's these huge databases that will allow you to receive information about, in Poland this morning we started seeing these types of emails floating around that were distributing this type of software, and they haven't gotten to work in the UK yet, but we've seen this and it's stretched. It's got to Germany now and it's moving across as people get to work. And thank goodness over here in the States, I get to work about 5 or 6 hours later than those folks in Europe do. And so if I'm subscribing to something that has a bigger world view, I can receive this information ahead of time and then use it with the machine learning component to automate the enforcement of security policies on the network. It's a living, breathing thing. Right? And I can automatically, push out security policies or firewall filters, access control lists out to my network. And it's automatic. I didn't have to program this manually to make my teeth fall out. And so software-defined secure networking, right? Software-defined networking, again, my heavens, does this mean we're going to centralize some things? Right? A centralized place where I can learn not only my network security stance, but also receive global information from external sources and use that information to dynamically deploy security policies out to the devices on my network. That's what we're trying to do, right? So learn threats that are out there and centralize the enforcement of policies on my network. We want to spread security everywhere, out to that switch that Fred was plugging that horrible machine in. I want security out there. I want to stop Fred at that level, right? His traffic will never get to the firewall, right? So I want to move from, security being right at the perimeter over there, to everywhere, in the switches, on the hosts, in the routers, in the firewalls, right? I don't want to have to do this with appliances anymore. Can I do this with some software? Because I can spin it right up in my cloud. I want it to be automagic. I want it to do what I want, not what I tell it to do. And of course, I want it to work with any vendor, in any platform, on any component I have. So it's got to be open, standardized, right? So what are the components from Juniper Networks dealing with software-defined secure networking, right? And again, the whole deal is it's not just my firewall that's providing security. It's my entire network. I'd like to be able to program security settings on any component in my network that will help protect me from the bad things out there in the world, right? And so let's look at some components that make this up, right? Excuse me. So some of the architecture, I want to be able to centrally manage. Remember, software-defined networking deals with the control being separated and centralized. Security policy. I want to have a component that can receive information externally about bad things that are happening on my network, and to be able to analyze that data and then use that information to dynamically program my network components, right? Push out policy all the way across the network. What happens now, right? Let's see how things are today. So, I've been looking at the logs we got last night. I do that every morning when I get to work. It's one of the first things after I get my coffee is I sit down and I run through the logs, look for any alerts. I've seen this the past couple of days. I think I'm going to go ahead and open up a ticket. That's always good. So open up a ticket, and that gets dumped off the security team's bucket. They get a day to reply. And then, okay, their reply is, okay, we're taking a look at it, and somebody picks up the ticket out of the bucket. It's Gus. He gets 48 hours to kind of resolve the issue, figure out, is this a false positive? Is this something we need now? It looks like we may have something here. We better call a meeting, right? We've got the Change Control Review Board meeting every Friday after lunch. How long does that take? You have that much time to fix this? We've got to figure out a fix, then we've got to test it, we've got to move it to staging, then we've got to implement it in production. There's a lot of, man, forget it. It's over, man. They've already stole your money, right? And so how do I want to do this? I want to automate this. I want it to be faster, right? So, I want to be able to learn, analyze security data from all the components in my network. I want to be able to leverage third-party external feeds. We're going to talk about one from Juniper called Sky Advanced Threat Protection, or Sky ATP. So I can learn about my network internally, receive information from external sources, and use that on something called or consolidated information on my software-defined secure networking policy enforcer, right? And this is what's going to kind of be the middleman here and push all these security settings out to my platforms on my network. And the components from Juniper that can perform these functions for you, we have an application called Juno Space. And this is a network management application that you can install applications on top of. And a couple of the applications that are required for the software-defined secure networking are two applications, one of them called Security Director and another one called Policy Enforcer. Now the Policy Enforcer is the one that plays the role of let me contact, learn the security alerts and alarms on your network, receive information from external feeds, analyze those, and then I can, if I see a particular threat, something I need to take action on, you as an administrator can define security policies that can be automatically deployed to the devices on your network using the Security Director application. That's what actually deploys the policies. So the Policy Enforcer analyzes security feeds, determines when policy needs to be modified, and the Security Director application pushes it out. That's the idea. So let's see a little bit how this works. Here's the Policy Enforcer component. This is the Juno Space application. And again, it can learn, it can analyze your logs from your firewalls and any kind of security logs from your switches and routers, receive information from the Sky ATP or any type of external third-party feeds, and use that information to dynamically program using the Security Director component SRX firewall policies, or if it's an EX or a QFX series switch, I can dynamically push down firewall filters to secure the actual port level, the access level ports on my network. And if it's third-party equipment, I can use, and if those third-party devices, that wireless access point or those third-party switches that aren't Juniper platforms, as long as those platforms support Radius and 802.1x type authentication, I can actually, push access control lists down to those components as well, because that's how Fred's connected. He's connected to that access point, that wireless access point out there. He's not plugging into the switch. He's a chatterbox. He's all over the office. So I got to pin him down wirelessly. And the security director is the actual component inside of Junospace that says, oh, okay, policy enforcer, thank you. I will go ahead and push that policy down to those hardware components so we are secure. And we didn't even have to have a meeting. And SkyATP, this is the external threat feed, and this is maintained by Juniper Networks. And so it's a cloud-based service that Juniper Networks provides, and it interoperates with our XRX firewalls. And it can provide threat feeds, and so my firewall can, instead of just making its decisions about, is this a bad file, is this a bad application, is this thing working right, just based on what it locally knows, it can leverage a global database of threat feeds through SkyATP or third-party feeds, right? And I can access that, right? And it provides quarantine services, so you can have your SRX firewall say, oh man, here's an attachment coming through in this, and here's a file being transferred. Let me quarantine that, and I can execute it externally in SkyATP and let me know, well, this is bad. This is a bad. You don't want this, quarantine thing. So it's really kind of a complete security solution here. I can learn from a global base of knowledge, threats that are being seen around the world, and I can have the policy enforcer push security policies using Security Director out and create enforcement points on my network and better protect myself, right? So that's kind of the function of SkyATP. And again, the switches, that's where Fred's plugging in. My heavens, if it's like I said, if it's an EX or a QFX series switches, I can have the policy enforcer or security director push down a firewall filter. If it's third party, we can use 802.1x and Radius to dynamically provision that wireless access point, right? But those would ideally be my initial enforcement points. That's the access line. That's how they get on. I'd like to nip this in the bud, senor, right? Okay. And again, from the Department of Redundancy Department, if it's a third-party device, if it's not a Juniper device, that's okay. The policy enforcer can use Radius and 802.1x to dynamically assign, VLAN attributes and put you on a quarantine VLAN or pass down a firewall filter or pass down an access control list and not thread off the network. He'll call you, right? Okay. All right, so that's the last chapter here. And so we talked about software-defined secure networks. The idea that, I need to push my security posture out to everywhere, not just the host, not just the firewall, on the switches, on the routers, on the wireless access point, on anything that somebody could use to access my network. I'd like to be able to control in a dynamic fashion. And so I do that by creating a central component, which is the Junospace Policy Enforcer application, to analyze security feeds from my local network, interoperate with external security threat feeds like Juniper SkyATP, and use that to create security policies that the Security Director application can deploy on my switches, on my firewalls, and any third-party networking components that make up my network. Software-defined secure network. And so those are some of the components, right? And those are the last three modules of our Cloud Fundamentals course. And you're going to be very successful if you take the time, as Lawrence mentioned at the start of the event today, and I think he mentioned this last week as well. I think you've got about 90 days to go over this material. Now remember, you need to at least get 5 hours in before, by Friday, right? And that's when Lawrence is going to, actually calculate the who gets a voucher thing, right? And so make sure you get that. But use this. This is great information for you. Remember to use the JNCIA Junos Cloud excuse me, I'm sorry, I'm getting a little tired. To use the JNCIA Cloud Practice Exam that's also available to you there on Juno's Genius. And that'll be a good gauge of your level of understanding of these concepts. You know, when am I going to be ready to take my exam? So you'll be, if you understand this material in this course, I think you really have a good shot of being successful. We all want you to get your JNCI Cloud certification, and then after that, keep going. Don't. That's just an associate level certification. As good as that is, there's a specialist level, professional level, expert level. Learn more. In this industry, the more you know, the more valuable you're going to be, the more opportunities you're going to find. So a lot of you may just be getting started in the networking world, and these are the things you have to do. You have to keep growing your knowledge over time. You're going to be outdated. You have to prove you're a good learner. You do it by obtaining these certifications. So once you get this one, keep going, right? I want to thank everybody for taking the event, taking the time to be with us. I know it's a big time commitment. It's a lot of work on your part, so I want to thank you. Buy more Juniper products, please. And people like Juniper. They like our products. They like our people. And I just want to wish you good luck. I think instead of keep babbling on, I'm going to go ahead and turn it over to Lawrence. If you have any questions, please put them in the chat window. I'll try to, kind of scroll back and answer some here, okay?
Yes, buy more Juniper products. I like that.
I like that too.
So yeah, no kind of greater words of wisdom than what Gordon just said about studying. You don't have to take the exam immediately, right? You've got some time to work with the material. You should put in a couple more hours by Friday just to make sure you cross that 5-hour threshold. But do take advantage of the material while you have access to it. 90 days is a long time to go through. And, check out all those other resources that are listed on the JNCIA Cloud webpage. You can get to at juniper.net/certification and just navigate to the cloud track, and you'll see all kinds of resources are called out, technical documentations, data sheets, things like that. Just lots of good stuff, to help you prepare for this exam. And, as Gordon said, you will be successful if you put some time into it. And just sort of last little bit, when you do take your exam, let us know if you pass it, right? We want to hear it. Send a note to education-services@juniper.net and let us know. And also, if you feel so inclined, we'd love your feedback on overall the open learning program. We'd love to hear, any kind of comments you have, what you liked, what you didn't like about open learning. And that's pretty much it. So I'll just double check, Gordon, if there were any particular questions in the chat window that you wanted to kind of drill into that were maybe not answered by other folks. I'll open a mic to you for 2 seconds to do that. Otherwise, we can wrap it up.
Hey, thanks, Lawrence. I was just kind of going through the chat window now. Hey, somebody would like to work for Juniper. We always need good people, right? We need all the good people we can get. So if you're a good person, you can go to our website, and there's a juniper.net/careers, I think it is. So we need good people, right? So please be good people and come work for us. So that's it. I think I've answered most of the questions in the chat window. If you have any more, please get them in there quick, and then we'll call it a session. Again, just thank you so much. Keep going.
I see Brian and Mike typing. Yes, Mike, the voucher will come in an email, probably be Monday or Tuesday. I'll run the report on Friday to kind of see how many I need to order, and then I'll send the request to Pearson VUE for the voucher codes. Then I'll get those on Monday or Tuesday and email everybody then. Any recommended resources for future learning? Just continue up the cloud track, would be my recommendation. If you take a look, this is JNCIA Cloud. Is the entry-level certification in cloud, and then there's the JNCIS Cloud and courses there. No other open learning versions other than JNCIA Junos, which you may or may not have, but there are certainly lots of classes. Maybe talk your boss into helping you with specialist level courses. And then, of course, there's third-party resources as well. Thanks, Alan. Yeah, I've heard that, Brian. True. We don't charge for it. Gordon and I can't keep the lights on. We're giving away $2,400 courses right here. So anyhow.
Thanks for making me laugh, Lawrence. Yeah.
Yeah, absolutely. That's my contribution. Cool. All right, we'll give it 2 more minutes. I'm probably going to go ahead and turn off my mic and just watch the chat window. Thanksgiving, everyone. Have a great balance of your Wednesday, or if it's Thursday, have a great Thursday. And good luck on your exam.